Okay, today we're going to talk about using trig identities to do integration with trig. So sometimes we have an integral with lots of trig functions in it, and we have exponents in it. And whenever you see exponents like this, I would always check first to see if it was substitution. So basically I'm looking for a u du situation. So if I made u sine x, then I have du cos x, but it's cos cubed. So that's not really going to work for me. So whenever I see a situation like that, I think about how I could manipulate this to make it a legit u du question. So what I do is I think about splitting this guy. So he's going to be cos x, cos squared x, sine 4x dx. So hopefully you agree that those are the exact same thing. And the benefit of that is I can change cos x to 1 minus sine squared x. So that's an identity times sine 4x dx. Okay, then I can distribute this. So I end up with cos x sine 4x minus sine 6x dx. Now the advantage of doing all of that is I have manipulated to create a u du situation. So if you see, I could make u sine x and a du dx is cos x. So I have the cos x part. So then I make fu u4 minus u6. Okay? So whenever you see something with coses and sines and exponents, think about what could I pick as my u and what could I pick as my du, and will it work to manipulate it? It wouldn't have worked the other way around, because if I picked sine x as my du, I would have a sine cubed x left over, and there's no identity I have for sine cubed x to change it into cos x. So basically I'm trying to make sure that whatever's left over once I take out the du is an even powered exponent. Okay, I hope that makes sense. So then this whole thing can be changed to u4 minus u6 du, and the integral of that is u5 over 5 minus u7 over 7 plus c. Then I plug in u, so sine 5x over 5 minus sine 7x over 7 plus c. Really, once you figure out what the plan is, what's your u and what's your du, the rest is easy, okay? So now I have a tan and a secant. So either u is going to be tan or u is going to be secant. So I need to think about that. If I made u tan, du is secant squared x, which I have. I have a secant squared, but I have secant cubed. So if I had a squared, I'd have a secant left over, and I don't want that left over. I only want even powered trig things left over, because then I use the identities to switch them. So let's think about if u was secant x, du would be secant x tan x, and I think I can make this work. So I want to have leftover secant x tan x. So let's right away pull that out. So I have tan squared x, secant squared x, tan x, secant x dx. So hopefully that makes sense to you. So this is my du part. My u is going to be my secant. So this I'm going to leave. This is good. So I need to switch tan squared x in terms of secant squared x. So tan squared x is secant squared x minus 1. And really the rest is easy at this point. So switch your identity, distribute that secant. And now I've set myself up, I've manipulated the situation, so this is going to be the du, this is going to be the u part, so u is secant. The fu is u to the 4 minus u squared. So the du is secant x, tan x, dx. Substitute in u4 minus u squared du, u5 over 5 minus u3 over 3 plus c, and then I go ahead and plug in my secant. So that's how we use trig identities to manipulate integrals so that I can change them into a u du situation.